Okay, I'll ask the first question, I guess, and hopefully it generates some more questions. So I think all of the talks, we heard a really broad spectrum, mental health to physical health, to development and the importance of time and looking at data across time. My first question for the panelists is has our understanding of sleep changed with the advent of AI and data science? What can we do differently, better? Anyone, sure, yes, Yushu.
Is this on? Can you guys hear me? I think that question is why I wanted to include the history of sleep medicine in the talk, because it really is driven primarily by collecting a lot of data and then trying to figure out how best to start actually distilling that into actionable outcomes. And so I think AI does it's enormous promise for this field in particular. We've always collected more data than we've known what to do with, which is exciting in a lot of ways that now we have at least some options with what to do with it. So I think one of the things to caution is just AI allows us to do things a lot quicker, but doing things quickly that maybe didn't have the strongest foundation is not going to be the answer. So a sort of relook at why we're collecting what we're collecting and how we're collecting it before we move on to, and we can do this really quickly and get this answer that we still don't know what to do with. So I think that's a huge caution. And also, like I said earlier today, this device development in sleep is exploding. And so understanding, at least for the clinical folks in the room, how to use what and when, and if it's relevant to your patient population is something that we just have to be cognizant of, because anyone can go get a meter or an accelerometer and think that they're actually getting the information that they want, and they may not be getting that at all. So I'll stop there.
And I also just mentioned, for our work, we weren't focused on sleep. I mean, everyone knows that there are sleep abnormalities in psychiatric conditions, but with the ability to measure things over longer periods of time in naturalistic environments, it was just that daily sleep patterns and all the abnormalities that we see that were the most striking. Of all the things we were measuring, the face and all these things, it was just, you couldn't avoid the fact that the sleep abnormalities were really striking, and so just zooming out of a human life, and you get past the sort of subjective noise of day to day, but you just see these really strange patterns of sleep. People who are getting 3 or 4 hours a night, people who have completely, seemingly random periods. It just starts to seem like something that all roads lead back to sleep.
That's what I think, anyway.
Can you all speak a little bit to, I think, right, like the sleep data? So Shu, you spoke to it, right? Subjective versus objective data. Right. And I think something really important for people maybe in the audience to understand is the temporal resolution of those data, right, is very different, right? A subjective survey report versus like actigraphy data. I don't know if we want to talk a little bit about that. That's important to think about.
Let me see if I understand what you're saying. Yeah, so actigraphy has tended to be something that so in the sleep clinic, you would give your patient a watch and a diary, and you'd say, do this for 2 weeks and then come on back, and then we'll look and we'll compare it to the polysomnogram, right? So I think, yes, the subjective experience of how and when you're sleeping and whether or not that's good for you. So there's also like, we can do the numbers and collect those, but then someone may say, but it doesn't really bother me so much. Or somebody may have a sleep state misperception where they don't actually feel like they're sleeping at all, and you bring them into the lab and they're actually sleeping 9 or 10 hours, but then you dig deeper into the micro architecture and you find that maybe there are rhythms intruding in there that look more like wake, and that this person's subjective report that had been poo-pooed for so long may actually have basis in their particular neurology. And so there's a ton about the physiology of sleep that we don't understand, and that there hasn't been a one-to-one connection between the subjective report and what we're able to understand. And so part of what AI might be able to do for us is marry or integrate those subjective reports with longitudinal activity data. And you had talked about the importance of wake being the really important counterpart of good sleep. with the physiology from the PSG. And I think that's something that now we can actually anticipate, we can imagine doing across huge cohorts of patients. We just really didn't have the computational power to do that before.
I have a question here. All of you presented powerful anecdotes, but I was impressed it's a lot of data points on few people. Reminds me of the days of trying to do a GWAS on 50 cases and controls until you discover you have to have tens and hundreds of thousands of people. So my question, is there anything inherent about AI to circumvent really getting very large numbers to eventually reach robust findings and, in a way, thematic saturations of the many things that you're showing on a bunch of people only?
Well, just quickly, the last slide that I put up, I didn't really have time to dig into, but over the last 5-6 years, we've been actively developing and contributing to the National Sleep Resource. It's a research resource, and it's funded by NHLBI. And when we met them, they had started as a collection of pulmonary. So they were looking at like obstructive sleep apnea in older populations. But it's exploded now, and it has over 50,000 data sets in it. And where they've moved toward is collecting thousands of data sets, including pediatric data sets, which is what we were really interested in, that gives us that power. And so there are a couple little slides sort of looking at, you take 3,500 kids and you start to map what their sleep electrophysiology looks like. That is much more powerful than where we've been. I will say also, though, that anecdotes have a lot of power, too, because what I study are the disease states, and sometimes those are rare disease states, and sometimes that gets lost in the big epidemiologic studies of normative data, or even of sort of like, you have to sort of have a huge signal to get outside of that. So I would say there's room for both of those things, but we are moving toward huge repositories to be able to collect and analyze this data. And I invite you all to go to sleepdata.org if you haven't already, and it is an amazing platform, and it can sort of answer some of those questions.
How about Dr. Baker's, you presented those few people there, and then you presented the norms from the UK Biobank. Where are you heading? More numbers, or finding patterns from the large and applying it to the small, or what?
I think that's the idea, right? You take epidemiologic scale data sets where you can then couch observations of individuals followed over time with respect to those demographic trends, right? So in my future world, we would have growth curves for speech rate, for sleeping patterns, for waking activity, for all the normal grooming patterns, and we would really be able to look at an individual level and say, for a 50-year-old male, no judgment, but you're doing this as 2 standard deviations more than typical for that age. And so it's just a window in, right? It's sort of like thinking about vital signs of how do we measure it in the right context or in a large enough demographics to then be able to zoom back into the individual without losing the resolution. Because I think where I was coming from, it was we would do the epidemiologic style studies and get it to the big data studies of hundreds or thousands of people, but there was never really much of an effort to try to apply that back. Or when we would try to apply that back to the individual, suddenly all the signal is gone. So I think we do have to do both, really, to recognize that those population level studies didn't have the context. So I think pairing these sort of more anecdotal, or I think of them as big data, but for N of 1, so following someone over enough time that you really do see those illness episodes coming in and out. Because I think, especially coming from sort of genetics and things, we need to really, especially in psychiatry, but I think in general in medicine, isolate the state-related factors from the trait-related factors. And I think to do that, we need to study both sides. But yeah, it's a great point.
And I'll
Another
just
question?
chime in. Oh, sorry. I'll just chime in about our Menninger data set. We have actigraphy data now for someone's length of stay, 4 to 6 weeks, so 24/7 data for about 70 patients. Our dream is that every patient comes to Menninger will have wearable-based data that we can leverage, right, and really leverage all that data across their whole entire length of stay. And so I think a larger data set, right, I don't know of a repository for kind of intensive mental health settings for sleep, but that would be,
We'll have to create one.
okay, next project.
I'd also just mention, we are doing, I didn't have a chance to mention it, but there's a large schizophrenia early prodrome study that we're part of that's following about 1,500 kids who are around 15 to 18-year-old. And that's over like a 2-year period. So that's at least getting into the bigger data, but not quite the population level.
Oh, hi. Just one question coattailing off of that. Have you thought about using AI to find the patients that would fit into your clinical studies?
Right, like, so using like electronic health record data to find the people who have
Right, so instead of going through
patterns.
spreadsheets of data and going through a highlighter to find out, oh, this patient qualifies, this patient would qualify.
Right.
Have you thought about looking into AI to help you find those patients quickly?
Absolutely. I think part of it is how do you get those data? So we're very focused on what are the denser data types that are feasible to measure on these settings. So we focused on the inpatient actigraphy because it's lightweight, and I mentioned briefly we're trying to get that into the clinical context. So now everyone who gets admitted to certain units or the whole hospital might be able to get those denser, almost physiological style behavioral data. And then, yeah, definitely would love to be able to identify, interesting phenotypes based on analysis of those data.
Excellent. The second question, the original question, sorry.
Oh, is that what you do?
I do. Yeah, we should talk. My original question was, how do you approach the data? There's two ways, right? One, you know the question, and you go and ask the data, like, that's one way. The second way is you don't know the question, you figure out like unsupervised machine learning, what does the data tell me? The reason why I ask this is because, there's a lot of conversation about sleep, you're a sleep specialist, because the reason why I'm getting into it is like, if you're a hammer, everything looks like a nail. So how do you approach the data?
Well, I'm interested I'm not a sleep specialist, so for me it was more about we're looking for across all of these sensors that are relatively easy to measure, between the face and watch and phone and so on. I want to see for each of these people that I'm working with, when they get sick, which sensors go off the rails, right? And I want to know that when they, as a doctor, I can see them getting depressed, I can see them getting manic. And so then the question is like, where do you see the signal? And then it's really it's sort of the Venn diagram of like, which signals are we able to measure either because the person's willing to wear the watch or whatever it is, and where is their signal that's not just changing, but changing in correlation to their mental health condition. So, and the idea is that could vary well and often is different per person. So that's sort of the way I approach it, which is to say, we're not even sure how many psychiatric dimensions there are, but we want to try to find patterns that are consistent for that individual and ideally consistent for that dimension in other people. So.
I'll just add to that and say, for us, we're really on the ground, right, in a clinic. And so for that, we are really trying to think about solutions that are hypothesis driven, right? So that, we aren't going into the data saying, what might be in here, right? An unsupervised kind of model. People have done that, and there's definitely a space for that. For us, we're really trying to think about, right, like concrete solutions that have support in the broader literature, and then how do we investigate that, right, to provide tangible solutions on the ground that have support from our own data, but then also from the broader literature too, versus kind of going in with a what's in this data kind of approach.
I actually think that's a wonderful question, and my short answer would be you can approach it many different ways. So, and it depends on if you're looking for something that's going to help you, like you're saying, like immediately on the ground with the clinical therapeutic decision. But one of the things that we've been doing the last 10 years is partnering with pediatric centers of excellence to build data libraries precisely to develop repositories to ask questions that we don't know we have yet. And so our general holy grail has always been to find those network configurations in the developing brain that will go on to predict children who will develop to have psychiatric disorders before behavioral presentation. And we think that there's a ton of information in the sleeping brain, not because it's sleep, but because that's when the brain is being built, that actually presages behavioral suffering. And so those types of agnostic approaches to databases are exactly why we're building these libraries.
Could you comment a little bit on the potential role of citizen scientists projects? So for example, on my Apple Watch, I've had a sleep app for, I don't know, like 5-6 years, and they're all commercial. So I'm assuming the data gets lost somewhere. I had to pay like 99 cents back in the day to get it. Every now and then I tell it how I feel. Usually I'm too lazy for that. But that could be a very good wealth of information if it's actually collected and tracked, especially with like the sleep report that you showed to the clinicians. I mean, I would go to the app much more often if I actually got something useful out of it, other than just telling me, oh, you're short on sleep, go sleep some more.
Yeah, I completely agree. I think citizen science, we're in the era now where people, I couldn't even do the work we're doing if it wasn't culturally normal for people to carry around phones and wear, smartwatches and things. So this notion that we're in a time when people are willing to label data, and they're interested in consumer technologies are providing, some framework for the design interface, like how to make it look pretty intuitive and things like that. So I think there's a lot of opportunity for that. And I think, I would love if we as a community, and I've thought a lot about like ways to crowdsource labeling of non-sleep type behaviors, just so we could begin, because a lot of the things that are abnormally presented in psychiatric conditions are normal behaviors occurring in abnormal contexts or with abnormal features. So if we had better population level labeling of all the common grooming behaviors and things like that, I think it would be amazing for mental health research and just behavioral research in general. I think it is a challenge because the consumer technologies that are out there are designed with one ecosystem in mind. So in the version that I was imagining, we would distribute like these more research grade accelerometers to everyone to do their labeling, and then we would maybe provide a dashboard so they could see what all their behaviors corresponded to or something. But yeah, I think it's a great point.
I want to give
That's good.
you
Thank
the
you.
last chance to comment, and I'm going to basically say, it's about lunch. Because I just thought with citizen science, you might have thoughts.
Thoughts. So my first thought is always, why are they collecting that data, and like what you said, and where is it going? And so you have to pay for it, which is interesting, because usually when people are, scraping data from you, they offer it as a free because they're getting something back. And then my other thought is that many of these devices in this space they have proprietary algorithms. So it's always hard to sort of unpack them and figure out actually, and I gave the example of the PPG, and right, with the consumer devices, they use a green wavelength. And so you're not really getting your O2 sat, but you think you are. So my thought about that is to just always ask, why is that being made available to you? And can you actually unpack what it's actually reporting to you?
Well, thank you guys so much for being here, sharing with us today.